All right, welcome back to linear algebra. Let's jump into Anki. All right. We've got no flashcards that are due. And so what I'm going to do is grade my work from yesterday, and then I'll be back to recall what happened. All right, so I got both problems from yesterday correct, which is great. So I'm going to continue doing more problems, and then I'll be back a little bit. All right, I actually just realized that I forgot to recall from yesterday. What did we learn yesterday? A fundamental problem is going to be for a given matrix, finding all the solution sets, potential solution sets. And so, finding all B, which are the constants that satisfy the equation AX equals B. If matrix A is invertible, well then there's gonna be every possible anything will work for B. Is that right? That doesn't seem to be right, but that's what I remember. I guess that makes sense. Okay, maybe. I don't know. I guess. And then if it's non-invertible, we'll basically have to use Gauss-Jordan elimination, or try to get the thing into reduced row echelon form, and then address any potential constraints from there. So fundamental problem. Oh, no. Find all values of B in which the equation AX equals B is consistent. All right. That's good for now. Let's continue doing problems. All right, so 13 was asking to basically find any constraints on the B's in order, or if any, in order that this, or actually AX equals B, these systems are consistent, I believe. Yeah, just linear system. And so the first thing I check is A invertible? Because if it's invertible, then we know by equivalence theorem that there are no constraints for B of the B's. All values of B's will lead to a consistent linear system. 15 was asking the same thing. I wanted to do another one because I wanted one where it wasn't going to be invertible, so I started with 15. Basically, I started out just seeing if A is invertible, but then I'm like, I can just partition the matrix of the B's on, and then I can solve both at the same time. So if it's invertible, then I'll know, and if it's not invertible, then I'll know. So eventually we get to it's non-invertible because this whole row is zeros, and if A is invertible, then it's going to be the identity matrix by equivalence theorem. So we knew the reduced row echelon form is not just a bunch of actually, is that necessarily true? Because I can eliminate. Can I eliminate the 2? And then multiply, no, I can't, because then we'll, yeah, no, we're good. So then we know that here, this row of zeros, the corresponding b is going to need to be 0. So simplified that out to b2 plus b3 must equal negative 7b1. And I feel like there was more that I needed to state, but this makes sense to me. This is the constraint. As long as this is true, then potentially then it should be consistent, I think, but we're going to find out if that's right or wrong tomorrow. And then there's the next question, 19. I'm not really sure. It says, solve the matrix equation for x. That's a capital X. And that's a ton in there. So, I don't really know. I'm not really sure what to do there. I guess I just said the question is the matrix equation ax equals b. Is that even true? I don't know. We're going to find out tomorrow. I guess I'm going to look that up. But that's it for today. Talk to you tomorrow. See ya.